Okay, so this is number 3 on the card sort, and I already, let me see if I can move this because I think it's in the screen. There we go. I already rewrote the function so that I could take the derivative, and then I already took the derivative. So now what I'm going to do is simplify the derivative so that it doesn't have a negative exponent, and that means that I'm going to put that term in the denominator. So we would have 1 over 3 x to the 2/3. And now that my derivative is simplified, I can go ahead and find my partition numbers. So my partition numbers are where my derivative is equal to 0, and then also where my derivative is undefined. So if I take this fraction and I try to figure out where this fraction is 0, I'm going to get no solution. And that's because the numerator is just a number. And if you even try to say, okay, I want to figure out where 1 equals 0, that's obviously never going to happen. So this derivative is never 0. If I try to figure out where the derivative is undefined, then I would set the denominator equal to 0, and I would get that, sorry, one second. I would divide by 3, and so I would get x to the 2/3 equals 0. And then technically what you're doing right here is to undo a 2/3 power. You raise both sides to the reciprocal exponent, so 3/2. And that's because if you take 2/3 times 3/2, you get 1. And so the left-hand side would just be x to the first. And then 0 to the 3/2 is just 0. So our only partition number is 0. All right, so we're going to go ahead and make a sign chart for the derivative. And then, like I said, our only partition number is 0, and it made our derivative undefined. Okay, so let's take this part of the derivative right here, and let's go ahead and plug in a negative number. So I'm just going to plug in -1. The numerator would just stay as 1, so that's positive. And then the denominator, the 3 you can kind of ignore because it's positive anyway. And so all we have to do is do -1 to the 2/3. And if you remember your fractional exponents, let's say you have a fraction of p over r, because that's power over root. So what you're technically doing, even though this isn't, difficult or anything, because it's 1. So what you're actually doing here is you are taking -1, and you can do this in any order, okay? You are taking the cube root of that, and then you are squaring it. Or the other way, you could do it in either order. And by the way, my dogs are running around chasing each other now, so sorry about that. Or you could do -1 and do the power first, so you could square it. And then when you're done with that, you could take the cube root. So whichever method makes more sense to you, you can do. If the number is bigger, you're going to want to do the root first every single time, because then you're going to make the number smaller. So you don't technically want to do the power first if the number is bigger. But again, just try it either way, and whichever way makes more sense to you. So let's go ahead, and we'll just go ahead and do it this way. If I have -1 and I square it, I get +1. And then if I take the cube root of a positive, I get a positive. So this is simply going to be a positive over a positive. So we have a positive to the left of 0. And then let's go ahead and do the same thing. Let's plug in +1. So if I put 1 into the derivative, the numerator is still 1, so that's positive. The denominator is going to be 1 to the 2/3. And again, you're taking the cube root of a positive, and then you're squaring that, so the result is a positive. So we end up getting a positive here. What you should notice about this derivative right here is the numerator is always positive because it's a positive value and there's no variable up there. And the denominator is actually always going to be positive too, because you are squaring whatever you put in there. So anytime you square a positive or a negative, the result is going to be positive. So this function is actually increasing from -infinity until 0. And then at 0, it has a vertical tangent line. I know it doesn't have a vertical asymptote because 0 doesn't make the original undefined. The cube root of 0 is 0, and then 0 plus 1 is 1. And then it keeps increasing. So this is what this graph actually looks like. Let me go ahead and just show you that. So here's that function. So it's the cube root of x and then plus 1. And you'll see that it's increasing, and then at 0, it has a vertical tangent line, and then it continues to increase.